we are going to start now lecture 4 of chapter 4 class 12th mathematics, determinants. In this lecture we will solve some more problems related to evaluation of determinants, and finally we will solve a problem based upon calculating the areas of triangles using the determinants. So the first question we have is, this equation is given to us and we have to solve it for x. So this determinant is given on this side. This is a determinant given to us and it is given that this is equal to x 0. This x is unknown and we have to evaluate the value of x. So to solve the value for x, we have to evaluate this determinant first. So to evaluate the determinant, look at this first row over here. We are talking about this first row. If we add the elements of the first row, we will get the answer is a plus x plus a minus x plus a minus x, that is equal to 3a minus x. Similarly, if we add the elements of this second row, we will obtain the same answer, and if we add the elements of this third row, we will obtain the same answer. So the operation we are going to apply over here, it is column 1 approaches column 1 plus column 2 plus column 3, and this determinant will become, the last two rows will columns will remain as it is, and this will become 3a minus x, 3a minus x, 3a minus x. This is determinant, so we must put the brackets in this way. Now we can take 3a minus x common from the first column. So the answer we are left with is 1 1 1, and these values we are a minus x, a minus x, a plus x, a minus x, a minus x, and a minus x. This value is a plus x. Now we know how we can solve this. With the help of this 1, we can make both these equal to 0. So we are going to perform the operation that row 2 approaches row 2 minus row 1, and row 3 approaches row 3 minus row 1. So we are getting 3a minus x, and determinant it is 1, a minus x, a minus x, and these values, these will become 0, and over here we will get it is 2x 0, 0 and 2x, and on opening this determinant we will get the answer is 3a minus x into this value. When you open this determinant along this first column, the answer you will get it is 2x into 2x, and it is given that this value is equal to 0. It is given that this value is equal to 0. So what we obtain is, we obtain either x is equal to 0 or x is equal to 3 times a. So this is the solution set for this equation. In this next question, again this determinant is given to us and it is given that it is equal to 0, and we have to solve it for x. So if we look at the terms over here, it is x minus 2 over here, and this time it is 3x minus 4, and this is 2x minus 3. So if we see something common in this, it is, in all these three cases it is x over here. In all these cases it is 2x and 3x over here. So the operation we are going to perform now, it is column 2 approaches column 2 minus 2 times column 1, and column 3 approaches column 3 minus 3 times column 1. So when we perform this operation, the determinant we get, it is x minus 2, x minus 4, x minus 8. When we multiply this term with the 2, we will get it, this term will become 2x minus 4. When we subtract it from 2x minus 3, the answer we are left with, it is 1. Similarly, the next element we will have, it is minus 1, and next it is minus 11. Next we are going to perform column 3 approaches column 3 minus 3 times column 1. So the answer we will obtain, it is 2 minus 4 and minus 40. Now with the help of this x minus 2, we are going to make these terms, we want to reduce these terms, so we are going to subtract these values over here, we are going to do row 2 approaches row 2 minus row 1, and row 3 approaches row 3 minus row 1. So now row 1 will remain as it is x minus 2, 1, 2. This answer we will get, it is minus 2, this is minus 6, this is minus 2, this is minus 12, this is minus 6, and this is minus 42. Now with the help of this term, we are saying from this term, if we look at this term and we look at this term, we can take 2 and 6 common. So we are writing 12 common. So what we get, it is x minus 2, 1, 2. We are taking minus 2 and minus 6 common. So we are left with is 1, 1 and 3. And over here we are left with is 1, 2 and 7. Now with the help of this one, we are going to make this 0. So we are going to perform the operation that row 3 approaches row 3 minus row 2. So this term will become 0, this term will become 1, and this term will become 4. So we have the new matrix over here. This term it is 0, this is 1, and this is 4. Now if we open this determinant along the first column, the answer we will get, it is x minus 2 into determinant of 1, 3, 1, 4, and then it is minus sign over here, minus 1, and determinant of 1, 2, 1 and 4. So the answer we will get, it is x minus 2, it is 4 minus 3, it is 1, and then it is minus this value we will get, it is 2. So the value, it is given that this value is equal to 0. So we will get x is equal to 4. So the solution set we have over here, it is x is equal to 4. Now in this next question, it is given that if a, b, c is equal to 0 and the value of this determinant is also given to be 0, we have to show that either x is equal to 0 or x is equal to this value. So to prove this, we are going to solve this determinant. So if we look at the terms over here, it is a minus x, this is c, this is b. If we add all these terms, the answer we will obtain, we add first row, we will get a plus b plus c minus x. If we add the elements of second row, we will get the same answer. If we add the elements of third row, we will get the same answer. So we are going to perform the first operation, it is column 1 approaches column 1 plus column 2 plus column 3. So all these elements over here, we obtain all these elements over here, they are a plus b plus c minus x. Now from the first column, we can take this term a plus b plus c minus x common. So all these terms now we have, it is 1, 1 and 1. These terms we have now, it is 1, 1 and 1. Now by using this first one, we can make both these 0. So we have performed the operation, we know these operations. Now it is row 2 approaches row 2 minus row 1, and row 3 approaches row 3 minus row 1. Both these terms will become 0, and these terms we obtain accordingly. Now when we open this determinant about the first column, the answer we are getting, it is b minus x minus c into c minus x minus b minus a minus c into a minus b. So when we multiply these terms, we will obtain the final answer in this form. Now it is being given that this determinant is equal to 0. So what we get is either a plus b plus c is equal to x, or we have x is equal to plus minus square root of, from the second term we are talking about, from this second part we are saying, we will have x is equal to plus minus square root of a square plus b square plus c square minus ab minus bc minus ca. Now it is given that a plus b plus c, it is given that a plus b plus c is equal to 0. So one solution we are getting over here, it is x is equal to, the value we are getting over here, it is x is equal to 0. This is one thing we have to prove. Next, if we look at this term over here, we have a plus b plus c whole square, that is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. The value of a plus b plus c, we have it is equal to 0. So what we get is that a square plus b square plus c square, that is equal to minus of 2ab plus 2bc plus 2ca. When we substitute this value over here, we obtain that the value of x is equal to plus minus square root of the value of a square plus b square plus c square, we keep it as it is. This a square plus b square plus c square we have. Now we have minus of ab minus of bc minus of ca. So from this term we are writing it is a square plus b square plus c square. Then it is plus 1 by 2 times a square plus b square plus c square. So the final answer we are getting, it is square root of plus minus square root of 3 by 2 times a square plus b square plus c square. And this is what we have to prove. Next we have is find the largest value of a third order determinant whose elements are 0 or 1. So if we write a third order determinant, say its element delta we are representing, its elements they are a1, a2, a3, b1, b2, b3 and c1, c2, c3. If we evaluate this determinant by expansion, we obtain that the value of the determinant, it comes out in this form. We have separated the terms with the positive sign and the terms with the negative signs. A and B can be now 0 or 1. Now this will attain the maximum value, this value will attain the maximum value if all these negative values we are saying, these should be equal to 0, and all these positive values, these are equal to 1. In this case, the value of determinant, that will be equal to 3. If we are saying that value of this term it is 1, value of this term it is 1, value of this term it is 1, value of this term is 0, value of this term is 0, value of this term is 0, only in this case the value of the determinant will be 3. But if we talk about that a1, b2, c3 is equal to 1, a2, b3, c1 is equal to 1, and a3, b1, c2 is equal to 1. So clearly what we can see from this, that a1 should be equal to a2, should be equal to a3, should be equal to b1, should be equal to b2, should be equal to b3, c1, c2 and c3, all these values should be equal to 1, because the elements of this determinant, they can be only 0 and 1. If any of these is 0, then these values will become equal to any one. If suppose we are saying c1 is 0, then this value will become 0, then the value 3 will not be attained. So it means all these should be equal to 1. And we know that if all the values of a1, a2, a3, all the values of this determinant, they are 1, then in that case the value of the determinant will be equal to 0. The determinant will become 1, 1, 1, 1, 1, 1, 1, 1 and 1. It means that this determinant cannot take the value 3. It cannot have the value 3. But if we try to write a determinant, if in this form, we are talking about this determinant, its value is 2. So what we can say that the value, this determinant cannot attain the value 3, but we can find a determinant with zeros and 1. This is a order 3 determinant. Its determinant is 2. So we are saying the largest value of the determinant that can be equal to 2. Similarly, in this next question, we are given that we have a order 3 determinant whose elements are now 1 and minus 1. In the previous case, it was 0 and 1. Now it is 1 and minus 1. So again, we are writing the determinant. We have expanded this determinant over here, and this is the value we are obtaining. Now we are saying that this will have the maximum value. The maximum value this can have, it can be equal to 6, and it will be attained if A1, B2, C3, A2, B3, C1 and A3, B1, C2, all these values are equal to 1, and B1, C3, A2, B2, C1, A3 and B3, C2, A1, all these values are equal to minus 1. These all values, we are saying these should be equal to minus 1. These all values should be equal to 1. In that case, the value of the determinant will be equal to 6. Now, if we multiply all these terms, we are saying all these values, these are equal to 1. If we multiply all these terms, what we will get? That AI, BI, CI, the product of all these terms, this should be equal to 1. We multiply A1, B2, C3, A2, B3, C1, A3, B1, C2. The final answer we should get 1 because all these values are equal to 1. From this second condition, we are saying if we take the product of all these values, we are talking about A1, A2, A3, B1, B2, B3, C1, C2, C3. The answer we will obtain that is equal to minus 1 because the product of these three will be minus 1. So we can clearly see that this product, in this case it will be 1. If we are taking the values in this way, it is minus 1. It means both these cases, they cannot occur simultaneously. So it means that the value of the determinant cannot be equal to 6. Now next, we are trying to write the determinants that we can write using the elements 1 and minus 1. So what we can do is, suppose we are saying, I am talking about different cases. The first case I am considering, if there is 1, minus 1 and 2 ones in the each row. We are talking about there is a minus 1, then it is 1, 1. Then it is 1, minus 1, 1, and then it is 1, 1 and minus 1 over here. In this case, the value of the determinant that comes out to be 4. Now suppose I am talking about the case there are 2 minus 1. 2 minus 1 means minus 1, minus 1, 1. Then it is 1, minus 1, minus 1. And then it is minus 1, 1 and minus 1. Now, it seems like these two determinants, they are different, but look at the values over here. If I take minus 1 common from this row, I am talking about minus 1 common from the first row, what this row will become? It will become 1, 1 and minus 1. I am taking minus 1 common from the second row, it will become minus 1, 1 and 1. I am taking minus 1 common from the third row, it is minus 1 common from the third row, it will become 1, minus 1 and 1. Now I am performing the operation that column 1 and column 3 are interchanged. This will become negative, this will become negative, these two will become positive. Now I am interchanging column 2 and column 3. This will become negative, this will become positive. So both these matrices, they are same except for this negative sign. Similarly, if we try to write the other elements, we can see that the maximum value is attained for this kind of matrices, and the maximum value of determinant that we can have, it is equal to 4. The maximum value of determinant that we can have, it is 4 over here. Next we have is the multiplication of two determinants of same order. So we are talking about two determinants. One is delta 1, it is this determinant is given, and this is delta 2. Both these determinants, these are 3 cross 3 determinants. So when we have to multiply these determinants, what we are going to do is, it is A1, B1, C1 over here. We are going to multiply this first row with the first row of this second determinant. We are going to multiply it over here. It is multiplied over here, and we get alpha 1 A1, then B1 into beta 1 plus C1 into gamma 1. Then this is multiplied with the second row. So we are getting A1 alpha 2 plus B1 beta 2 plus C1 gamma 2, and then it is multiplied with the third row. So this is the third element we are getting over here. Similarly, in the next step, we will start with this second row. We multiply it with all the 3 rows again. We multiplied with this first row, we will obtain the answer in this form. With the second row, we will obtain the answer in this form, and with the third row, we will obtain the answer in this form. When we were talking about the matrix multiplication, what we were doing, we are multiplying this first row with the first column over here. Now over here the condition is that multiplication of determinants of same order. In case of matrix multiplication, we were saying P cross Q, Q cross N. These Q should be equal. The answer we were getting, it was P cross N matrix. But when we are talking about multiplication of determinants, they should be of same order. We are saying the answer we are getting again, it is a 3 cross 3 matrix, and corresponding columns, they are multiplied over here. So if we have to evaluate the value of this determinant, what we are going to do, one thing we can do is that you have to evaluate the determinant, this determinant, you have to evaluate this determinant, and finally you have to multiply the value. So in place of this, what we are going to do is, it is 1, 2, 3. This is the first row over here. It is to be multiplied with the first row over here. So answers we are getting, it is, when we multiply these values, the answer we are getting, it is 1 into minus 2, it is minus 2, then 2 into 1, it is 2, then 3 into 3, it is 9. Next is 1 into 3, it is 3, then 1 into 2 into minus 2, it is minus 4, and next it is 3 into 1, it is 3. So we are getting the terms in this way. And when you solve these values, you will obtain the determinant in this form. The multiplication, by multiplying these determinants, you will get this answer. So to solve this determinant now, we have performed the elementary operation that column 1 approaches column 1 plus column 3, and column 2 approaches column 2 plus column 3. And after this we have performed this operation. You can try at your own. Now you know how to calculate the value of the determinant in this case. So you will obtain this matrix in this form. This is reduced to this form, and we now open this determinant along the second column, and we obtain that the answer is minus 1725. This is the final answer we have obtained. Now next we have an important property. It is if A1, B1 and C1 respectively are the cofactors. We are talking about A1, B1, C1. These are the cofactors of the elements A1, B1 and C1 of the determinant. We are talking about this. This is the determinant given over here, and this is the determinant we are talking. Its elements, they are the cofactor of A1, cofactor of B1, cofactor of C1, cofactor of A2, likewise. So our property says that if the determinant of this, we are saying delta is equal to determinant of A1, B1, C1 A2, B2, C2 and A3, B3, C3, then the determinant of the corresponding cofactors C1 matrix formed by corresponding cofactors, that will be equal to delta square. It means if the determinant of this matrix is 5, then the determinant of the matrix with the cofactor it will be 25. So the proof of this result, we are saying if we multiply these two terms over here, we are talking about, this is the first determinant we are talking about, this is the second determinant which is formed by the cofactors. These two determinants we are talking about. If we multiply both these determinants, we know that how we multiply the determinant, the answer will be A1 plus B1 plus C1. This will be the first element over here. Next, this first row will be multiplied with this second row over here. We are talking about the multiplication of determinants. So that will be A1 into A2, B1 into B2 and C1 into C2. Likewise, we will obtain the third element. Similarly, we will have elements over here. Now, we know that the value of this, we are multiplying the element with the corresponding cofactor. This will give us the value of determinant, and this value will be equal to 0. These are the cofactors, these are the elements, and we know that this value is 0. This value is 0, this is 0, 0, 0, 0, and these values we have over here, these will be the determinants over here. So the final value we are obtaining, it is equal to delta cube. We are saying that the final value, the determinant over here we are getting, it is delta cube. So what we have obtained, I am talking about this result, it is delta into this matrix. The answer we have, it is equal to delta cube. So we obtain that the value of this cofactor, determinants of these cofactors, that will be equal to delta square, and this is what we have to prove. So we obtain this result. Next is, we have to show that this determinant is equal to this value. So if we calculate the cofactors corresponding to the matrix we are considering, suppose A we are saying it is x c minus b minus c x a, then b minus a x. We are writing determinant of A is equal to, say, delta. If we write the cofactors over here, we are writing another matrix. The cofactor corresponding to x, it will be x square plus a square. Then corresponding to C, that will be minus cx plus ab. Next, corresponding to minus b, that will be ac minus xb. This is a plus xb. So likewise, we will obtain these results over here, and this is basically the cofactor corresponding to this matrix A. So the determinant of this matrix will be equal to delta square, and this is what we have to prove. We are considering this value, it is delta. We are having square over here, so we are saying the determinant of this matrix, that will be equal to delta square. Next is, we have to prove that the determinant square of this matrix, that is equal to this value, and it is equal to these two values. So first of all, we have calculated the determinant corresponding to this matrix. We are saying this is the determinant we are calculating. We expand this determinant and we obtain the answer as 2abc. This thing you can try at your own, you know how to solve the determinant. We are getting the answer as 2abc. So square of this value will be 4 times a square b square c square. So we have proved that this value is equal to this last value. Next, coming to the second step, we are saying this is square over here, so we are writing it is 0cb, c0a and ba0. We are multiplying this matrix, this determinant with 0cb, c0a and ba0. So when we multiply these, we are talking about, this is the first row over here, it is to be multiplied with first row. The answer we will obtain, it will be 0 plus c square plus b square. Next will be a into b, next will be a into C. Likewise, if we will calculate the next values, we multiply now the second row with first, second and third row, then this third row with first, second and third row, we will obtain this matrix. So we are saying we have proved the result that this matrix, the square of this matrix is equal to this particular value, And the last part we are talking about, we have to prove that it is equal to this value. So this is basically, we are saying if we are writing delta is equal to, minus of a square ab ac, ab minus b square bc, and ac bc and minus c square. This is basically the determinant of the cofactor of delta. So if we are talking about the matrix 0 cb, c0a, ba0, so what is cofactor corresponding to the term? If we are talking about corresponding to 0, the cofactor we have, it is corresponding to this 0, the cofactor will be a square. We are writing it is minus of a square. Next, corresponding to c, it will be ab. Then corresponding to b, it will be, from this term it will be ac. So this matrix that is given to us, this matrix we are talking about, this is basically the cofactor of this given determinant. And we know that the determinant of this cofactor, that will be equal to delta square, and this is what we have to prove. So we have proved all these results, that this determinant of this matrix we have calculated, it is 2abc. We have done the square over here, we have obtained this result. Then when we multiply these two matrices determinants, we are obtaining the result over here. And third result we are calculating by using the result that determinant of cofactor of delta, that is equal to delta square, and hence we have proved that all these values, these are equal to each other. The next result we have is to express a determinant into product of two determinants. So this is just the previous formula we are talking about, that we have already studied, that this is one determinant given to us. This is the second determinant given to us. If we do the product of these two determinants, we will obtain the answer in this form. Now if we look this result in the converse way, we are saying that if this determinant is given to us, then we can write this determinant as the product of these two determinants. So first result we are having, similarly this is for 2 cross 2 matrices, similarly we can see the result for 3 cross 3 matrices. So this is the matrix given to us, and we have to prove that the determinant of this is equal to 0. So if we look at the terms over here, we are having, it is alpha 1 over here, beta 1 over here, this is alpha 2, beta 2, alpha 3, beta 3. Similarly, we have A1, 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 then it is B1, B1 and B1. So what we can see from this, that we are talking about the product of two determinants. One is A1 multiplied, then next element it is B1. I am looking at this term over here, there is no third term, so we are writing it is 0 over here. We have multiplied this term with, first of all we have multiplied it with alpha 1, beta 1, 0. Next, second step, we have multiplied it with alpha 2, beta 2, 0. And next we have multiplied it with alpha 3, beta 3, 0. Next terms we have, it is A2, B2. It is A2, B2, A2, B2 and 0. And the last term we have, it is A3, B3 and 0. So if we do the product of these two determinants, we will obtain this given determinant. And as this column over here it is 0, this column over here it is 0. So the value of both these determinants, the value of this determinant is 0, value of this determinant is 0. So we are saying the product of both these determinants is 0, and this is what we have to prove. Now the next question we have to prove that this result cos of a minus p, cos of a minus q, cos of a minus r, determinant of this is equal to 0. So if we write these terms over here, we write the formula over here. We have it is cos A cos P plus sin A, this is into sin P. We are talking about cos A minus P, then cos A minus Q will be cos A cos Q plus sin A sin Q, and last will be cos A cos R plus sin A sin R. Next we will have cos of B minus P, so that will be cos B cos P plus sin B sin P. Next will be cos B cos Q plus sin B sin Q, and last will be cos B cos R plus sin B sin R, and similarly we can write the third term over here. Now if we look at these terms over here, we are talking about these values. It is cos A sin A cos A sin A cos A and sin A. It means the determinant we are talking about, it is having in the first row cos A sin A and 0, and it is multiplied with, it is cos P sin P, this is cos P sin P and 0, then it is cos Q sin Q and 0, and last it is cos R sin R and 0. Next, moving on to our next step, we have cos B sin B and 0, cos B sin B cos B sin B, and next terms we have it is cos P sin P, this thing we have already seen, then it is cos Q sin Q, this thing we have already seen, cos R sin R, this thing we have already seen. Similarly we can write for the third row. So again in these determinants we will have this last column, we have it is 0, so the determinant of both these, it is equal to both these, the determinant is 0, so the final answer we are obtaining for the product of these two, it is 0, and this is what we have to prove. Next is, if alpha, beta and gamma are real numbers, we have to prove that this determinant is equal to 0. So we are writing this determinant in the form, in place of this 1, we are writing it is cos of alpha minus alpha, next it is cos of beta minus alpha, next it is cos of gamma minus alpha. It is cos of alpha minus beta, cos of beta minus beta, and the last term we will have it is cos of gamma minus beta. And similarly in the third row we will have cos of alpha minus gamma, cos of beta minus gamma, and cos of gamma minus gamma. Now as we have solved in our previous question, similarly we can write this as the product of two determinants. One is cos alpha sin alpha 0, cos beta sin beta 0, cos gamma sin gamma 0 into determinant of cos alpha sin alpha 0, then it is cos beta sin beta 0, and the last will be cos gamma sin gamma 0. Again both these columns we are talking about, they are equal to 0, so the final answer for the product we will have it, that is equal to 0, and this is what we have to prove. Next is, we have to show that if A, B, C and X, Y, Z, these are the real numbers, we have to prove that this determinant is equal to this value. Now we can see that if we look at the terms over here, talking about how to approach this question, it is A minus X whole square. If we open this whole square, we have it is A square minus 2AX plus X square, and the answer we require, it should have 1 plus AX whole square, that is equal to 1 plus 2AX plus AX square. So it means we have to arrange these terms in such a way, we have to arrange the terms of this matrix, we have to separate them, we have to rearrange them, and we have to convert this form to this particular form. So we start solving this by opening the whole square of all these terms. It is shown over here. We have, this is the given determinant we are talking about, and we have opened the whole square of all these terms. It is a minus x whole square, we are writing it is a square plus 2ax plus x square, b square plus 2bx plus x square. And this determinant we can write it as the product of two determinants. The first being, look at the terms over here. It is basically, if we look at this term, it is 1 into a square. Then next it is plus 2x into minus of a, and next it is plus x square into 1. I am talking about this first term over here. This term we can write it in this form. Similarly, we can write all other terms in this form. So what we can see is, this value 1 is there. We have separated it in two different determinants. We have written this determinant as a product of two determinants, and it is x square over here. Similarly, rest of the terms, it is a square minus a and 1, because we want to adjust these values of a over here. So we have separated the values of a. Now the next step we have done, we have rearranged the columns over here. We are saying this is column 3, it has reached to column 1, and this second column we are talking about, minus abc is there, minus sign we have taken common, it is over here, and this a square, b square, c square. So what we have done, we have interchanged the column c1 and c3. So one minus sign is there because of this. And the second thing we have done, we have taken minus 1 common. So this minus sign is there. So we obtain this given determinant, we have written it as the product of two determinants in this form. So because of this minus sign is removed, what we are looking over here, it is 1 plus ax, and this is a minus x square. So because of this step, this minus sign will be converted to the plus sign, and now this x square was there, this a square is over here. So we are getting the terms in the form ax whole square. So we have the determinants in this form. Now if we multiply both these values, if we multiply both these determinants, we will obtain it is 1 plus 2x plus a square x square. Next it is 1 plus bx plus b square x square. Next it is 1 plus cx plus c square x square. Now if we write the values of these terms, this is basically the whole square over here, 1 plus ax square, this is 1 plus bx square, and this is 1 plus cx square. So we are obtaining this determinant in this form, and this is what we have to prove. So in place of solving or evaluating both the determinants, we have just rearranged the terms and applied the basic properties that we have already studied, and we obtain the given answer. We have obtained the given result. Next we have the formula for the area of the triangle in terms of determinant. So we know that if the vertices of a triangle are given, these are the vertices of the triangle, it is x1 y1, x2 y2, and x3 y3, then the area of this triangle, it is given by this formula. It is given by this formula, and this formula, it can be written in this form, that it is basically the determinant half, this value is there, half is there, and determinant of x1 y1 1, x2 y2 1, and x3 y3 1. If you will open this determinant, you will obtain this answer. So we have opened this determinant along the first column, you will obtain x1 into y2 minus y3, next minus x2 into this term, and plus x3 into the term over there. So this is the formula for the area of the triangle in terms of determinant. Now an important thing to note over here is that if the value of the determinant we obtain, it is negative, then we take the positive, that is absolute value of that result, because area is always positive. Next is if 3 points A, B, C are given to be collinear. Collinear means they lie on in a straight line. We are saying there are 3 points, they lie on a straight line. It means the triangle they will form, it will have the area equal to 0. It means the area of the triangle formed by these 3 points, that will be equal to 0. So to prove that the 3 points are collinear, we can prove that the determinant, this determinant value is equal to 0. So based upon this, we solve certain problems. The first is find the area of the triangle whose vertices are, these are the vertices given to you. A is -2, 3, B is 3, 2, C is -1 and -8. The formula for the area we know, the formula for the area is 1 by 2 x1 y1 1 x2 y2 1 x3 y3 1. Now in place of x1 y1 x2 y2 x3 y3 we substitute this value, we obtain the answer is equal to -15. So the area of this triangle, that will be equal to mod of -15, that is equal to 15 square units. Next is prove that these 3 points, these are the 3 points given. A is A comma B plus C, B is B comma C plus A, and C is C comma A plus B. These are the 3 points given. We have to prove that these are collinear points. So to prove this, we are going to write the area of the triangle which is formed by these 3 points. First point it is A, next it is B plus C, next it is 1, then it is B, C plus A 1, and next it is C, A plus B and 1. So if we will solve this determinant, the area is given by 1 by 2 into this. We are saying suppose these 3 points A, B, C, they form a triangle, they are not collinear. If they are not collinear, then the area of that triangle will be given by this. To evaluate this, we are going to this determinant, we are going to perform C1 approaches, C1 plus C2, we will get it is A plus B plus C, A plus B plus C, A plus B plus C, this is B plus C, C plus A plus B, this is 1 1 1. Now look at this column over here, we can take A plus B plus C common, we can take A plus B plus C common, this term will become 1, this is 1, this is 1, both these columns, these are identical, so the determinant is equal to 0. So we obtain that the area of the triangle formed by these points, it is 0. It means these points, these are collinear. So it means these points, now these points are collinear points. Next is if the points A, B, A dash, B dash, A minus A dash, B minus B dash, these points are collinear, we have to prove that A, B dash is equal to A dash, B dash. So again, we have written the condition for collinearity. We are saying these points are collinear, it means this determinant, the value of this determinant is equal to 0. Now if we open this determinant, we will obtain the required result. To solve this determinant, again you can perform the operation that row 1 approaches row 1 minus row 3 and row 2 approaches row 2 minus row 3. We will obtain 1 B minus B dash, A minus A dash, these two terms will become 0. When we are doing row 1 minus row 3, the answer we will obtain it is A dash, B dash over here. And when we are doing row 2 minus row 3, the answer we will obtain, that is equal to 2 times A dash minus A, 2 times B dash minus B. Now when you open this determinant, you will obtain that the final answer you are getting, that is equal to 0. On opening this determinant, we are left with this, it is not 0, we are left with this A dash into 2B dash minus B minus B dash into 2A dash minus A. So when you will solve this, you will obtain it is A B dash minus A dash B is equal to 0, this term. So what we get is that A B dash is equal to A dash B, and this is what we have to prove. Next is find the value of K so that these points are collinear. Again, these are the 3 points given to us, these are collinear, given to be collinear. It means the determinant 5 5 1, K 1 1 and 10, 7, 1. This determinant should be equal to 0. So when we solve this determinant, we will obtain the value, it is equal to 2k plus 10. So we can perform the operation that row 2 approaches row 2 minus row 1, row 3 approaches row 3 minus row 1. This determinant will become 5, 1, 1. These two terms will become 0. Then it is k minus 5 and this is minus 4. Then this is 5 and this is 2. So on opening this determinant, we will obtain that this opening along this third column, we will obtain it is 2k minus 10 plus 20, that is equal to 2k plus 10. And it is given that these points, these are collinear, it means this value is equal to 0. So this implies us that the value of k we have, that is equal to minus 5. Next is let A, B and C, these are the 3 points, such that area of triangle ABC is 3 square units. We have to calculate the value of k. We know that the formula for the area of triangle, it is 1 by 2 times the determinant of this value. From where we are getting this determinant, it is 1, 3, this 1 is there, then 0, 0, 1 is there, k is 0 and 1 is there. When we solve this determinant, we are saying that the area is 3, it means the value of this determinant can be plus minus 3. So when we solve this determinant, we open it along this second row. The value of determinant we obtain on solving this, the value of determinant we obtain, it is minus 1 into minus 3k, that is equal to plus minus 6. So the value of k we obtain, that is equal to plus minus 2. So this is the required value of k, for which the area of this triangle ABC, that will be equal to 3 square units. Next is find the equation of the line joining the points A, B using the determinants. So suppose we are saying that any point on this line, it is P is x and y. We are talking about there is a point 1, 2, there is another point 3, 6. We want, this is the point A, this is the point B. We want to find the equation of the line. We are considering any point over here, it is P x, y, which lies on this line. Then what we will have, these 3 points, these should be collinear. If these 3 points are collinear, it means the determinant 1, 2, 1, x, y, 1, 3, 6, 1. The value of this determinant should be equal to 0. When we solve this determinant, we obtain the result as y minus 2x is equal to 0. So this implies us y is equal to 2 times x. So this is the required equation of the line obtained by joining the points A and B. So this is how we can use the determinants over